In this video, we're going to recap our knowledge on distance time graphs. We're going to do this by completing the following 3 learning objectives. These are describing motion from distance time graphs, calculating the speed of an object using a distance time graph, and at the end of the lesson, there will be some higher tier only content where you'll learn to look at tangents from a distance time graph in order to calculate the speed. During this video, you will need pen, paper, and calculator. So please pause this video now and go and get those items if you need to. We have learned about the difference between speed and velocity. Speed is a scalar quantity. This means it only has a magnitude. Speed is measured in meters per second. This is different to velocity, which is a vector quantity. It is speed in a direction. In this video, we're going to learn how to represent the speed of an object graphically. We're going to look at the first learning objective, which is being able to describe motion from distance time graphs. If an object moves along a straight line, the distance travelled can be represented by a distance time graph. Distance is plotted on the y-axis and time is plotted on the x-axis. In this example, the object is stationary, because as time increases, the distance does not increase or decrease. This means the object is not moving. So a horizontal line represents stationary motion of an object. In this example, a car is moving along a road at a constant speed. We can tell this because the graph is showing a straight line. The gradient of the line is not changing. This means that the distance travelled every second is the same. In this example, the car travels 10 meters every second, so the speed of the car is 10 meters per second. The table of values used to create this graph would look like this. We're now going to complete the second learning objective, which is calculating the speed of an object using a distance time graph. The speed of an object can be calculated from a graph by working out the gradient of the line. The gradient of the line means the change in y divided by the change in x. The change in y is the distance and the change in x is the time. The symbol delta represents the change in. The change in y in this graph is 10 meters for every 1 second. Therefore, the gradient of the graph is 10 divided by 1. Therefore, the speed is 10 meters per second. The speed of any object can be calculated in this way by drawing a straight line down from a point on the line and drawing another straight line across from the point on the line. The length of the line y divided by the length of the line x gives you the gradient of the line. This makes sense for our stationary object too, because the gradient of the line here is 0, which means the speed of the object is 0. So the object is stationary. But what about when the line is not straight? What if the line on the graph is curved, such as this line? What does that tell you about the speed of the object? In this example, a motorbike is travelling along a road, but the graph does not show a straight line, so this is not travelling at a constant speed. We can see from the graph that the distance travelled each second is increasing. In other words, the speed of the motorbike is changing. The motorbike is accelerating. its speed is increasing. So we can see that every second the speed is increasing. Here is a table of values that would be used to plot a graph like this. This shows us clearly that the distance covered each second is increasing. For example, between 0 and 1 seconds, the distance travelled is 5 meters. Between 1 second and 2 seconds, the car travels an extra 10 meters. So this distance travelled has increased, so the speed of the car must have increased to travel further in a given amount of time. Please now pause the video to complete these two multiple choice questions. You also need to complete these two multiple choice questions, so pause the video now and complete these. Here are the answers to the multiple choice questions. Question 1. The gradient of a distance time graph represents the speed. It is important to note that it is not the acceleration, as this is what you can get from a velocity time graph. Question 2. A curved distance time graph represents an object which is moving at a changing speed. If the gradient is changing, then the speed is changing. Question 3. Which is true of the object's motion represented by the graph on the right? The graph shows a stationary object because the gradient is 0. As time increases, the distance does not increase. Question 4. Which of the following best describes a tangent? A tangent is a straight line which only touches the graph at one point. And we will look more at tangents in the higher tier part of this lesson. We are now moving on to the application task part of the lesson. In these questions, you have to describe the motion of an object, shown by the graph. A model answer for this question would read like this. As time increases, distance increases at an increasing rate. The gradient of the line is increasing, therefore speed is increasing. So we say the object is accelerating. Now we can tell that the gradient is increasing because the line is becoming more steep over time. Remember, if the gradient is changing, then the speed is changing. As this gradient is getting steeper, the speed is increasing, so the object is accelerating. You now have some gaps to fill in for the we do. This graph is slightly different because you can see that the line is curved, but then it becomes horizontal at the top. So you need to think what the speed would be, calculating these tangents up the curve and coming to a horizontal line, and what that means about your speed. So please pause the video now and complete the fill in the gaps for the we do. The answers to the we do are as follows. As time increases, distance increases at a decreasing rate. The gradient of the line is decreasing. Therefore, speed is decreasing. So we say the object is decelerating. Eventually, the gradient is 0. So the speed is 0 and the object is stationary. We can see that the gradient of the line here is decreasing because it becomes less steep. And a reminder that if that gradient changes, the speed must be changing. So if the gradient's becoming less steep, the speed is decreasing. Really well done if you noted that as that gradient reaches 0 at the top, and the line becomes horizontal, that must mean that the speed of the object is 0. Please now pause the video and complete the You Do section. The answer to the You Do part of the application task, where you also had to describe the motion of the car shown on the right. As time increases, the distance from home decreases at a decreasing rate. The gradient of the line is negative, and the gradient is increasing. Therefore, the car is travelling home, towards home, and slowing down. Eventually, the gradient is 0. Therefore, speed is 0, and the car is stationary. Please use this time to pause the video and self-assess your answers with your green pen, adding in any extra information that you've missed. Once you have done this, continue the video on to the next part of the application task. This part of the video is for higher tier content only. This is for students in Set A or B, or anyone studying separate science. You will need to be able to calculate the speed of an object using a distance time graph. To work out the speed at any given second for an object that is changing speed, we will need to create a straight line. We will need to draw a tangent. A tangent is a straight line that only touches a curve at one point. This means this allows us to calculate the speed at that given time. Make sure when you do this, you use a ruler to make it as neat as possible. In this example, the line in red is a tangent drawn to the curve at 10 seconds. We know this because this is the point where the tangent touches the curve, when the time is 10 seconds. This will calculate the speed of the object at 10 seconds. And we're going to use that same triangle method to work out the gradient of the line. So working out the gradient, the change in the y, which is our distance, is 8, and the change in x, which is time, is 8. The gradient of the line is therefore 8 divided by 8, so the gradient is 1. This means that the speed of the object at 10 seconds is 1 meter per second.